Hey everyone! In the previous video we talked about writing half equations, and one thing I didn't mention was that in those examples that we did, we wrote all of our half equations in acidic conditions. In this video we're going to be learning about how to write them in basic conditions. So we're going to talk about number one, the different types of redox conditions, why these conditions are important and how they can present themselves in questions, and finally we're going to talk about how to convert from acidic to basic conditions. So, basic conditions for redox equations. When we're talking about redox equations and the half equations that we wrote in the previous video, they were all occurring in acidic solutions. Often when we have redox reactions occurring in things like batteries, they're usually actually occurring in basic rather than acidic solutions. So, how can we write these half equations to occur in basic conditions, and what does it mean when I say acidic? So if we scroll up to our previous video, you'll remember that in step number 3, when we were balancing hydrogen, we'd balance it by adding H+. Now, H+ ions make substances acidic. So if we add lots of H+ ions to something, we increase the acidity. If we decrease H+ ions, we decrease the acidity. So in the steps we learned, step 3 was inherently making an acidic environment. In this video today, we're going to talk about how we can change this and make our equations into basic environments. So these are the steps. Number 1 is to literally just write a half equation in acidic conditions. So we literally do everything we just learned in the previous video normally. We just write it in acidic conditions first of all, and then after that we learn how to convert. So step number 2 is to convert from acidic to basic. And the way we do that is by, first of all, adding OH minus to neutralize H+. So as I said, H+ makes things acidic, OH minus makes things basic. And if we go H+ plus OH minus, we end up with H2O, water, and this is neutralization. So I'll show you guys how to apply that in these questions. And next, we simplify the equation and we cancel our H2Os. So I'll show you guys what that means in a second. Now, these are the main steps required for converting between acidic to basic conditions. So why might we actually need to do this? In VCAR questions, whenever we find redox, they will usually tell us whether it's acidic or basic conditions. If they don't specify and they do require us to write a half equation, it'll usually be in acidic conditions. However, most of the cases, VCAR will specify whether acidic or basic conditions. So when we know the conditions are acidic or basic, and one of the questions, let's say question 2b for example, is write a half equation. Oh my god, what is that? Write a half equation for x to y. Then we will write them in either acidic or basic conditions depending on what was specified to us. So it will almost always be given whether or not stuff is acidic or basic, and then we base our half equation writing around the information given. So in the previous video we used the example of Cr2O7 and we ended up with the equation looking like this: 6E minus plus 14H plus Cr2O7 2 minus was aqueous as well, let's say, goes to 2Cr3 plus aqueous plus 7H2O. That was the final equation we worked out over here. So now let's convert this equation to a basic condition, because as you can see, it's currently in acidic. So step number 1 is to write our half equation in acidic conditions. We've just done that. Step number 2 is to add OH to neutralize H+. So as you can see on the left-hand side, we have 14H+. So if we want to neutralize this, this is what we're going to do. I'll just skip states for now to save us some space. So what we do is we neutralize the 14H+ by adding 14OH- to both sides of the equation. So we add 14OH- plus 14OH-. So just like in maths, when we do something to both sides of an equation, the same thing applies here. Now, we can simplify this further because, as I said, H plus OH- gives us H2O. So on the left-hand side, we now have 14H2O plus 6E- plus Cr2O72-. And then we get 2Cr3 plus 7H2O plus 14OH-. So what we've done here is we've simply combined our OH and our H+ to provide us with 14H2O. And our 14OH on the right-hand side stays the same. And now part 2b is to simplify the equation by cancelling H2Os. So as you can see, on the left-hand side, we've got 14H2O, and on the right-hand side, we've got 7H2O. So what we can do is cancel stuff out a bit. We can get rid of the ones found on the right-hand side and simplify this entire equation down to 7H2O plus 6E- plus Cr2O72- goes to 2Cr3 plus 14OH-, and that is our final answer. So we've pretty much done our steps for the example we used in the previous video. We've converted our Cr2O72- to 2Cr3 plus equation, and we've converted it from acidic conditions to basic conditions. That's all there is to it. Just remember that we always start out by finding the acidic conditions equation, and then we convert it to basic via these two simple steps. That's literally all there is to this video. Any questions? Ask me as always. Thanks for watching, everyone.